this company, YSIG Networks Private Limited, which focuses on advanced 5G technology. He is a key member of TSDSI and Bharat 6G Alliance, leading efforts to develop 6G standards in India at 3GPP and ITUR WP 5D. He works closely with the Government of India to shape the country's 6G plans, has also authored over 200 international patents, including crucial ones used in 2G to 5G standards and the products. With those words of introduction, I hand over to you, sir. And I would like to just apprise you that we are running short of time. I would request you to kindly close this session latest by 5:30 p.m. Thank you. Over to you, sir.
Can you hear me well? Hello?
Yes, we can.
Okay, thank you. It's first of all, my apologies for not being able to present. Something came up in the last minute. I'm privileged to moderate this session with many experts here sharing their views and experience on this very important topic, machine learning and artificial intelligence and potential applications in 5G. I would like to actually share one slide that just recently published by ITU 145D, if you allow me. I will show you a picture rather before we start the session. Let me just show you the picture. My friend Vishnu is here. He was present in this picture taken in Geneva just a few weeks ago. Can you see this picture? I hope you can see this.
Yes, we can.
This is the photo taken at Geneva right after publication of IMD 2030 Vision and the Requirements. You can see all the contributors there from across the world who worked very diligently over the last 2 years to publish this vision. And you see that famous hexagon here,
Thank you so much, Kiran. So without taking much time, uh, I haven't prepared a great slide. So I'll start with, so I had a dream 2 days back, a AI dream. In that AI dream, I woke up, and as I woke up, I saw a very comprehensive health report that is generated by a AI using the nanobots that are flowing in my bloodstream. Then as I walked out of my apartment, there was a autonomous car, self-driving car, that picked me from my apartment and was scheduled to drop me at my office. In the car, I had a virtual assistant, right, that gave me an update of the global news and the calendar that I had for that day. While I was looking outside the window, right, there were a lot of billboards, etc., in the languages that I don't understand. But my smart glasses actually translated all the text real time, right? When I reached office, I had a meeting with my global team, and in the team, there were people from different nationalities, different languages speaking, but I was conversing with them in my native language, right? All in real time, and everything that was happening was like I was meeting them in person. So guys, why is this possible, right? This is not a dream. This is the near future. And this is going to be possible only by AI, complemented by 5G. The apps that are going forward to come, right, they have massive data requirements, and all that data requirement and the low latency that they need, right, that can only be possible through 5G and 6G networks. So while I talked about these apps, right, the apps that are going to basically use 5G are virtual reality, precision medicine, remote surgery, interactive AI assistant, real-time translations, edge computing, and many more. So as I think the 5G network evolves, right, there will be multiple and different use cases that will be coming along, right? So I just talked about how AI is enabled by 5G. So let me take a step back and talk about how 5G is enabled by AI. So you all know Airtel, right? India's biggest telecom network, right? And Airtel has around 350 million users, right? Spread across the country, speak different languages, right? And Airtel is also now has launched 5G in almost all the cities in India. How AI is helping telco, right, like Airtel, is first is customer service. So, you know, having such a large customer base, it's almost very difficult to basically have a call center dedicated, right, that can speak to each and every customer complaint. So what Airtel does is, first, we have our conversational AI. So what I mean by conversational AI, all the conversations, right, let's say if you call a call center in Airtel, right, all the conversation that happens on Airtel call center, they get through a speech analytics system, which translates or transcribes all the calls, and it rates the call on the quality score. So by this, we are able to provide best of the class customer experience to our customers, all through by AI. The next is, if you have used Airtel Thanks app, right, you will find there is a chatbot. So most of the queries that you have for your plans, for your queries, for your complaints, right, are generally answered by chatbot, which is multilingual. So this is the power of AI, how we are able to serve 350 million plus user base through AI. The next is network optimization, right? Having such a large network, right, there's a massive amount of network data that basically transports, right? And you need AI in order to basically analyze all the network data and make necessary changes so that you can provide best of the network experience. The next is network security. So if you see everything, right, everything is data, right? Data is moving right through our 5G networks, right? If the network is not secure, right, it's useless, right? So what we need is sophisticated AI algorithms, right, that basically checks network for anomalies and basically ensures that the network is very fully secured. The next is network slicing, right? Everyone has different data requirements, right? So how AI can be employed is AI can analyze the network usage of the individual and create virtual network, right? So that the need of every individual is catered right to the best. Besides having a great infrastructure, 5G infrastructure, right, I would also like to touch upon there are 3 more parts of this ecosystem, right, that are very, very crucial. The very first one, AI platforms, right. So having an AI platform where developers can learn, train, develop, and deploy, right. This kind of AI platforms, there are many cloud organizations that are building, right, is very, very important to have a very sound ecosystem of AI with 5G. The second is IoT devices, right. So a lot of AI apps that we talk about, right, they work on data that will come from IoT devices. So we need a platform, a very strong IoT platform that basically gives all the data through the sensors it has. The next is the data analytics platform with huge data coming in, right, from our 5G networks, right. There is a need of having a very, very strong data platform in order to crunch and analyze this data. In the last, what I want to say is that AI and 5G go hand in hand. I would like to take a comment from Mr. Raj Kapoor. He said Bunty and Bubbly, right? So if Bunty is blockchain, I would say Bunty 2 is 5G for AI. Thank you.
Thank you.
Kiran, over to you.
Yeah, thank you, Rohit. Nice comments, well said. Let's move on to the next speaker, Dr. Srihari Vasudevan, Principal Data Scientist, Ericsson's Global AI Accelerator at India. With expertise in statistical modeling, data fusion, and machine learning, Srihari has a strong scientific track record with 40 publications and more than that patents. He applies his skills in various domains like robotics, mining, natural resources, and financial transformation. Currently, he focuses on AI/ML solutions for 5G telecom and strategic studies for 6G. Passionate about social impact, he develops AI/ML solutions for healthcare, education, and sustainability, enjoying collaboration and education through mentoring, teaching, and public speaking. Thank you, sir. We'll be glad to hear from you. Over to you.
Thank you. Am I audible? All good? Yeah, thank you for having me here. I'm very grateful to be able to represent Ericsson in this forum, full of eminent speakers and a great panel. So I think Rohit's talk actually gives me a nice segue. So we are looking at some of the interesting applications that AI and 5G are going to bring about. But coming from an Ericsson standpoint, let me take a slightly different complementary viewpoint. How is AI going to enable all this? Okay, so we are looking at it as what can AI do to 5G and 6G? Okay, how is it going to enable it so that these applications are realizable? I'll come to that. I'll approach this problem from that lens. Okay, so let's start by why do we need AI for 5G and 6G? Long story short, with every generation, with every new generation, you have more devices, more users, higher data rates with lower latency expected. Okay, so as soon as you have these increasing demands coming up, okay, it effectively becomes an effective resource utilization problem where the resource is not necessarily just a spectrum. We're also thinking in terms of energy efficiency. Okay, as soon as you have more users, more devices, more network traffic, you also have more dynamics in the network. So you need to be able to adapt to the changes in the network much more and much faster. Okay, so till now we have largely been reactive. So when something occurs in the network, you respond according to some policy. Okay, so the reactive automation has been the norm, but we need to go into proactive automation, and in fact we need to go towards autonomy. Human in the loop is great, but human doing everything is not great, right? So we need to move towards some level of autonomy. Okay, so that brings me to what are the key AI enablers that are going to enable 5G and 6G as we see it. Okay, so obviously, in fact, we'll start from the bottom. The applications obviously drive innovation. Okay, so there are as we go towards 6G, we'll have this whole Internet of Things, and I mean the whole Internet of everything. In fact, the whole connected machines, the machines talking to each other, sharing data and enabling different applications. Then you have the whole XR-enabled, applications. You also have, Ericsson trying to enable the UN SDGs, okay, by connecting more people in remote parts. All of those things are going to drive innovation. But in terms of purely the AI technologies, I'll group them into 3 buckets, okay? Compute, data, and autonomy, okay? And I'll spend a bit more time on autonomy, okay? So, and they are not mutually exclusive, they are linked. You could potentially look at it from, one of these technologies in the other bucket. It's totally possible. So in the compute side, okay, we started with physical network functions, okay? And then we moved to virtualization technologies, we moved to virtual network functions. These days, everything is moving to the cloud, right? So you have cloud network functions. So as soon as we are moving to the cloud, we bring in the whole hyperscale cloud providers, Google, Microsoft, IBM, all of them, provide cloud services. But the point is, they're not just providing a platform or an infrastructure, they also provide AI services. So if we as Ericsson are going to build our solutions in these HCPs, okay, the question is, what are the integration challenges? What are the interfacing challenges? How do they affect the latency? Because anything we do, we have to look at what is its impact in the network performance. So these are some of the challenges that we are trying to address as of today. Okay. The next thing that comes into the plan is distributed compute. Okay. So you could have compute in a big data center at the core. That's fair enough. But you could also move that compute all the way to closer to the edge. Okay? And I would argue that it's actually a better idea because transmission of data is always more expensive than transmission of information, meaning processed data. So if you could move the processing of data as close to the user or as close to the end application as possible, okay, which means moving into the edge, then you're going to be saving big on resources. Okay? And it's going to make your compute better. It's going to make your quality of experience better. Okay, so as soon as the question is when and how or where to deploy the compute as close as possible to the user. Okay, so as to guarantee certain SLAs. Okay, now fine, I have AI models that I deploy closer to the edge. Very good, but who's going to take care of the complete lifecycle management of these models? When does this model need to be updated? When should it be swapped for another model? The entire lifecycle operations of such distributed model setup, okay, is a complex task. So you have this whole MLOps dimension coming in over here. Then there's the huge security dimension, which frankly is going to only grow bigger and bigger because of cloudification, in fact. So when I say security, it's both AI for security as well as security for AI. Okay, so AI enabling security, cybersecurity. Okay, and there's also the AI models. Just a few days back, I came across a paper where they have a trained neural network model. And in the weights, they're actually injecting malware. So you have to secure your AI models also. So that's another dimension that's becoming important. Trustworthy AI is another dimension that we're looking at very actively. How do you know that the AI that you have developed is actually doing what it's supposed to do in an ethical and responsible way and not something else? Okay. So then there's the angle of data. Okay. So yes, we have petabytes of data, but as you know, telco is highly regulated, and it's not like as a scientist I get access to petabytes of data without any checks and balances. Okay, and it's a good thing, right? So, but the question is, do we actually need petabytes of data to come up with meaningful insights? Okay, oftentimes what you need is less data but relevant data. So we're moving from the whole notion of you need big data to you need smart data. You need data at the right frequency, at the right time, okay, and the relevant data for a particular use case. So we are trying to use AI to generate data that is relevant to us for a particular use case, and thereby make it smaller but relevant data. Okay. Then there's this whole concept of digital twins, which may be useful for both assessing what actions, network actions, will result in before actually implementing it in the network and causing some disastrous situation. But there's also the aspect of, can I generate more data? It is possible to use digital twins for that as well. Then there's the whole concept of domain compliant AI, and something which I believe is very, very relevant for telco. Meaning, you can't just produce an AI model and expect the telco industry to take it, because telco is a very domain-rich, it's not an emerging domain. There's a lot of expertise. There are experts who know in and out of different facets of the domain. So when I build an AI model, I need to make sure that it complies with the domain. There are certain domain expectations of how that model should perform under different circumstances. Does it comply or not? So there's a domain-compliant AI angle that we look at. And there's, of course, generative AI. Yes, there are, which has, of course, we think about LLMs and ChatGPT, fair enough. But, generative AI has been around for much longer than just this, the past couple of years. But yes, there are, several efficiency-based use cases that we're looking at from the text angle, but there are also other modalities. Coming from a telco angle, we also look at audio. We also look at, tabular data, which is relevant for, building some of these AI use cases, okay? And now coming into autonomy, and I'll spend a little bit more, just a few minutes more on this, which is, we are dealing with an explosion in terms of devices, in terms of applications and data, and we need to be able to cater to this quickly and adaptively, right? So we believe that it calls for a new way of a new paradigm of of AI in telco. So till now, what has been the norm is really telco native AI, as we call it, which is building AI applications for telco, which is more like AI applications for telco as in AI features in a telco application. It's more of a bolt-on kind of thing, okay? Whereas AI native, which I will show you in the next slide, okay, is really about having AI in all facets of of a telco solution, from the design to the development to the deployment to its operations and its maintenance. All aspects of a telco solution are designed by AI. So that is what we are looking at, okay, as of right now. And there's a public article. If you just Google for AI native and Ericsson, you will get this article, and this table is available there. We have studied this AI native from many different dimensions, and what you want to take away from this is that there are different levels. At the lowest levels, you've got what you have today, which is standalone code, standalone solutions, which might be a single AI function that doesn't really talk to any other AI functions. But at the highest levels, you've actually got AI designing AI, and that is where we are headed, okay? Lastly, I leave you with one concept, which is that of intent-based networks. One way of realizing what is called a cognitive network is what's called an intent-based network. And so this is a different paradigm. So let me put it this way. Let's take a simple example. If you have a latency problem, if the latency is beyond a certain threshold, there are fixed policies on what you can do to resolve that situation. One of them might be increasing the packet priority. The other might be move the user to another virtual machine which is less loaded, and therefore he's better served. Things like that. Okay? So in all of these cases, you have to specify the policy, or you can maybe learn the policy from data, fair enough. But if you have to do it for every device or every user separately or every situation separately, it becomes a bit of a problem. A more scalable way of achieving autonomy is through this intent-based network, where me as a business user, I just specify that the latency has to be within a certain threshold. And the AI in the network over here will figure out, there are actually measurement agents that are continuously measuring the latency. If it exceeds a certain threshold, okay, automatically issues are generated. Those issues are picked up by proposal agents who leverage knowledge to know that, okay, under these circumstances, I can increase the packet priority, or I can, move the user to another VM. These proposals are evaluated. I cannot just implement a proposal without understanding its impact to the wider network. So they have to be evaluated by an evaluation agent, and the best proposal is actually taken into actuation. So the difference is, in the former case, we were looking at an imperative paradigm, where I specify how the entire policy has to be specified, or it has to be learned. In the intent-based paradigm of realizing cognitive networks, we are really just specifying the desired state, and we expect the network to figure itself out, figure out how to achieve that state using its local circumstances, data, and knowledge. That's where we believe this is headed. These are the transformation technologies we believe which, are going to enable us to realize 5G advanced, 6G, and beyond. Thank you. I'll leave it at that.
Really fascinating to listen to you. I wish we had 1 hour slot rather than 10 minutes. So we have to move on. Let's invite the next speaker, Mr.
Okay, good evening everyone. I think before I start, I just want to confirm, Professor, is it real you or it is your digital twin talking?
No, it is not artificial intelligence.
Yeah. So there is actually an anomaly in the word AI because, it says artificial. We all know that it's already real. So good evening everyone. My name is Manoj. I'm from Nokia. And so the way I have structured my presentation is that I'm going to do it in 3 parts. I'll first of all talk about a little bit of technology vision. I think that's very important for us to know which direction we are going. So maybe by 2030, which direction is the world going? How will the networks look like? How will the bandwidth requirements look like? Where is traffic going? What are the use cases which are emerging? And once we, have the idea about that vision, only then we'll be able to kind of appreciate how is AI going to help us in this journey, right? So I think that's the way, my flow is going to be. So let me start with Nokia Bell Labs. Nokia Bell Labs doesn't need any introduction. It's got an illustrious 100 years history. And the main philosophy of Nokia Bell Labs is that we address the real human needs through the human intellect, which means whenever we identify a global problem, we put the best of the engineers, best of the scientists, the researchers, and they kind of address the issue. They go to the root and come up with the solution. I think that's the philosophy which Nokia Bell Labs follow. We started with transistors. I think you would have heard about William Shockley and the gentleman without whose discovery of transistor, the information theory wouldn't have existed. We talk about information theory, Shannon, exactly 75 years before. He was the one who actually gave the Shannon. And all these discoveries actually happened in Bell Labs. We are doing huge amount of work in metaverse. In fact, almost more than 10 years before, the Bell Labs researchers, they predicted that digital twins will be the reality. It's pity that we did not come up with this term called digital twins, or rather metaverse. Otherwise, all the predictions which we are making today, they were predicted almost 10 years back by the researchers at Bell Labs. And we are doing a lot of research in neural networks, even the telecom technologies, so on and forth. So let me start with the first part of my presentation, the technology vision. We at Nokia believe that there will be 2 enablers which the world is going to see. The first is what we call it as human augmentation, which basically means that the communication which we do today will have more augmentation, so more VR, more XR kind of flavor, which will lead to huge amount of uplink traffic, and huge amount of traffic is going to be estimated. Today we talk about petabytes. It's going to run into, by a factor of almost 1,000 zettabytes, as they call it. The second enabler is what we call it as digital physical fusion. It's basically the amalgamation of the physical and the digital worlds. Everything which is physical today will have its digital avatar. In fact, digital twins is already a reality. If you YouTube digital twin, you will already see that companies like Siemens, BMWs, they are using digital twin in a big, big way. Right from the product inception to the product management to the maintenance, almost in the entire life cycle, it's almost a reality today. Right? Soon you will actually have a digital twin becoming more sophisticated. It'll become more feature rich. It'll also take the consumer route, right? When all of us will also have our digital avatars. So keeping these 2 enablers in mind, we believe that there will be no one metaverse, but there will be 3 metaverses. So there will be industrial metaverse, which I told you is already a reality today. That will actually need operational technologies, robotics, automation, sensors. The second would be the enterprise metaverse, which is like co-design, co-create, collaboration, something which we are already witnessing today, right, already. So we believe that the first 2 metaverse, they are already the reality today. The third type of consumer metaverse is going to take a little while. And for a true consumer metaverse, we believe it might take 5G advance. It'll get started with 5G advance, but I think it'll really fructify in 6G era. So keeping this vision in mind, how do we actually prepare ourselves? How is it, how all of these use cases will be possible? The network, as we all know, will be the underlying fabric, right? And if you look at the future network, it's granted that all the new bandwidth requirements, latencies, the massive connectivity, all these things will be there. You know, like we keep saying, it's like more of the same, only better. So these three pillars will be same, and like Professor Kuchi already mentioned, the triangle becomes the hexagon, so there will be three more pillars. The pillars of sustainability, this that's the fourth pillar. The fifth pillar will be that of cybersecurity and privacy. And most importantly, there will be the pillar of intent-based autonomy, right, AI, and which is what is going to be the fulcrum of all these things which will be made possible. So AI, therefore, is not going to be the enabler. It is going to be the bedrock of all the technologies if we look forward. We at Nokia Systems, we believe that our research and the innovation will be resting on the four pillars. Network fundamentals, I kind of already touched upon. When we talk about automation, I think we have a very different philosophy. We believe that automation, we don't want to replace human beings. We want to coexist, we want to collaborate with the human beings, right? And that is what actually was the first point when we say human augmentation. There is no replacement which people are trying to create with the technology. So that's the fundamental pillar of the automation which we talk about. We kind of automate the low-skilled jobs so that people are able to focus on something bigger. The fourth and the most important part, and which is actually the topic of the discussion today, is the AI and the software systems. And I'm actually going to go deep into that. Okay, so AI and telecom. If I look to a typical telecom network, given the fact, I mean, India as a country has got 4 generations of technologies, right? We have 2G, we have got 3G, 4G, 5G, tomorrow it will be 6G also. The vision document is already released. The operational complexity of such a network, we believe, will increase by a factor of 50x, right? We talk about the spectrum assets, huge amount of spectrum assets, millimeter wave, you know, low band. Tomorrow we'll talk about terahertz. It's only going to get very, very complex. Look at the densification of the base station sites, right? Huge amount of small cells, heterogeneous networks, HET nets. It's only going to become more and more denser. If you are an engineer, telecom engineer, you look into the configuration parameters, you talk about thousands of parameters when you're trying to configure your network. When you talk about the managing this network, you know, the wealth of data is enormous. And then we have the huge amount of complex spectrum assets to manage by. All this will be humanly impossible to manage. And therefore, we believe that the rule-based software systems which we talked about, right, they are going to very soon hit the saturation limit. So you need something more, and that answer will have to come through intent-based automation, which we call it as AI, which eventually will need to what we call it as cognitive autonomous networks. Let's look at some trends. Some interesting study by McKinsey. And what McKinsey did was that they did some scenarios. They said that what happens if your data growth grows by a factor of 25% or a 35%, 50%. And you'll be surprised to know that the total cost of the ownership really zooms by a factor of 100%, 300%, you know, when the data increases by such a factor, for the reasons I just explained in the previous slide. The only answer to bring down and bring the efficiency and the productivity would be possible only through AI. And that's precisely the reason that we have started to see all the big telcos, and that's my graph on the right-hand side, clearly showing that huge amount of investments will be done by the telcos in the AI area. So having established this baseline, let's now talk about what's already happening. Now let's talk about what's happening in the operations side, right? So AI into operations. I already talked about the configuration management. The network will be learning itself, it'll be predicting and therefore trying to self-configure, right? So that's the benefit we get, more operational efficiencies. When we talk about fault management, we move from the preventive maintenance to the predictive maintenance, right? So self-healing networks. Security, again, exactly the same. Before you actually, so you are basically able to act before actually a security bug arrives. So we are talking about the networks which will think, which will sense, and therefore act on their own, which we call it as cognitive networks. Let's talk about, I think that's the first area which we talked about. The second benefit which we foresee is in terms of optimizing the networks. For the reasons I already explained, how do we do the capacity management of the network? How to ensure that the capacity goes in the areas where there is traffic? How to ensure the parameters optimization? How do you do the energy savings? How do you switch off the transmitters? How do you predict all these trends? So I think AI will actually have a huge say in terms of ensuring that we are able to optimize our networks to a great degree and therefore leading to the cost efficiencies, right? We talked about spectrum sharing, we talk about automatic beam steering, which means ensuring that the antenna beams move in the direction where the user is, where the traffic lies. So that was a little bit on the network side. Let's talk what's happening on the subscriber side. And this to a certain degree is already happening today, right? I mean, we see subscriber insights, you are able to predict the churn, and if you are able to predict your churn, you are able to actually plan your campaign management accordingly, right? You are able to devise your next product based on your customer needs. So all that automation we are already able to see. We already are seeing the chat boxes, the AI assistants, doing the job, what a normal customer care agent would be doing. So I think this is something which is already happening today. Little bit on the vendor management side, we also see a lot of AI assistance happening in managing the complicated supply contracts, right? So contract management, the use of tools like AutoML, AutoCares, etc. So I think that's started to happen and will contribute in a big way. If you look at the journey, I mean, we are at the 5G era today. AI has just been started to use, right? But we do have some challenges, and those challenges are, we have the proprietary AI ML solutions today, right? For example, there are very good energy management solutions which are AI ML based, which are actually being used even today in Indian networks, and they have actually resulted into huge amount of energy savings. It's already being used by most of the telcos now. But for AI to be really productive, you need to train. And for training, you need huge amount of data. And it's important that if you're transporting such a humongous amount of data, it has to happen on the standard interfaces. Otherwise, we'll be creating the islands. And when we are creating a lot of islands, I think we'll never get the benefit of AI. Because if you're not able to train your networks properly, you'll never be able to do the AI modeling properly. You'll never be able to come up with some very good algorithms. So that's important. And we are starting to see the standardization and the AI ML enhancements in 5G Advanced. 6G, we already talked about. My Ericsson colleague already talked about the AI native system, which we foresee in 6G. But even before that, in 5G Advanced, we'll start to see AI ML in air interface, and we'll actually start to see AI ML in most of the other network functions. So with that, I think I'd like to conclude. I keep saying that as we move forward, AI is never going to be artificial. It's going to be the reality, and it's going to be native AI ML, which is going to be the bedrock of all the future technologies. Thank you very much.
Thank you, thank you very much for the excellent remarks.
Thank you, Kiran, for the introduction, and thank you, and happy to be part of this eminent panel. So I will, being the last speaker, I have an advantage. I just have to cover things which are not covered. So hopefully I will do that. So I will just cover the aspect which we all like has been discussed by other panelists. So from 5G to 6G, the main change which is supposed to happen is it will become sort of AI native. How are we taking the steps? So I will speak specifically from the standardization perspective on what exactly is happening in standards. Though this is mostly from a 5G perspective, I'll just put some effort, some effort which is happening in India, academia, as well as industry towards 6G transport as well. There is some effort going on towards what is called the advanced optical communication. So what exactly is happening? So I have 3 slides. One is on system. At a system here means that you have the core. I also include a transport aspect of it, and then the radio. Then I will explain it under RAN level what is happening. What exactly is the information we are trying to take from the system so that that data can be fed for the AML system which can use it to learn it. So there are 3 aspects which are being done at a system level. One is called network energy saving. Here what we are trying to do is like, basically this is expected from the industry to reduce the total energy consumption and the CO2 emission aspect of it. See, right now, if you see how the most of the systems work, most across all the industry elements, it's like you put a threshold. If there is no user in a particular location, you basically shut down the entire base station. So there is no way where we could actually restrict it to some mechanism of threshold where I can basically ensure that the user is not there. So can I maybe allow him to connect to a nearby base station, and if he has enough, what you can say, the enough signal strength, SINR, etc., he may be allowed to connect to a bit more farther away base station so that the one nearer to him is shut down. So all those aspects would need some coordination across multiple base stations. And the other thing is like this information would also need where the users are spread out. How are the users moving around? What are their locations? So these are informations which are not right now used. So if you see, many of our decisions which happens are based on what are called the received power and received signal strength, etc. So this additional information which you would be getting is about the user location, etc. Can I use it in a better way? The second thing is about mobility optimization. So one of the issues which happens is whenever I am moving from one base station to the another base station, if I know the user location and if I can estimate his velocity at what point he would be moving from location A to location B. There are improvements which are done, which are called conditional handovers, etc. We could use that to ensure that he has a seamless handover from point A to point B. So this is the second aspect which is worked in at a system level in standardization. The third thing is about load balancing. So if you have multiple base stations or if you have to distribute the load across multiple things, again, across 2 base stations, a user is in between. Should he connect to the base station 1 or base station 2? So this is another aspect which is being worked in standard on how do we do it. Again, this needs some additional information which I will explain in next slide. At a RAN level, what is happening is about channel estimation. So this is a major problem in any radio network. In the channel estimation, we actually would have to figure out what is called the CSI information, which actually includes multiple things like the rank indicator, PMI, etc. So those information, can I improve it based on the user location? And if I know that the user is especially moving towards the base station or away from it, can I do something better? This also would further get enhanced when I have the RIS coming in, which is the intelligent reflective surface or the reconfigurable intelligent surface. I would, knowing the location of the user, I can use the RIS properly. The second part, which you would have heard of, is in 5G, you do a lot of beam-based user basically connects to multiple beams. How do you hand over from one beam to another? The managing the beam is not so trivial because you have now, it's roughly like earlier you had 3 sector, now you have say 10 sector or something like that. So how do you manage that? So this also requires some, how do you handle the latency reduction? So these are the other aspects. The third thing is that can I improve something at a positional accuracy, because you have quite a large number of improvements which have happened from 5G or 4G to now 6G. You have earlier TDOA, you have now an angle of arrival. All these informations are available. So now the positional accuracy is much, much better than what you could have got. And this is possible even in an indoor scenario, which even GPS was not able to provide you the location. So now I can use my radio base stations around to get a much better positional accuracy. So can I use this to improve the scenario? So all of this is where AML is being used, both at RAN and system level. From an optical perspective, where it is being used is basically there is something called elastic optical network. The elastic optical network is like, if you want to see how it gets evolved, is you add more and more transponder, muxponder card into an existing system. So you basically increase, if you have an 100 gig, and optical is also evolving at a much faster pace. So you have the 400 gig coming in, 800 gig supposed to come in soon. So each of this, you put an additional transponder, muxponder card. So you are creating more path. How do you ensure that you distribute the traffic across multiple of this? So there are all of this, if you see from a AML perspective, these are all time-dependent things. So there are some of this which are also, you can see the eye diagram which we call. So if you can look at the eye diagram, make a corresponding image thing, you can use it for network correction or whatever. So those are usually done by CNN, but most of the other things are done by RNN-based models. And the last thing is, what exactly are we doing, right? All of us are getting into this whole thing. There was a whole bunch of things about ethics, etc. Here, we are not doing anything quite more than what you would have already been giving. One is that we are actually taking UE measurements, which includes, in addition to all the RSSI, RSRP, your serving cell ID has always been part of the information which was shared. We'll get more location information, which is like how fast are you moving, or what direction are you moving. All of those information are also used for that. The second part is about how do I minimize the drive test. So it's basically, this is also has been happening from 4G time. The whole idea is, do I need to send actual person to measure the channel? How do you assign, like that's a very complicated problem of how to tilt my antennas, ensure that there is coverage everywhere, and you get that signal. So that part is being looked at, the MDT part of it is being looked at. The third thing is the interface, which is like basically what are the additional XN interface, which are the interface between two base stations. How do you share that information so that even if you deploy Ericsson, Nokia, or Tejas equipment, all of them can work together and provide same level of capability. So basically, if you see from all of this perspective, there is nothing scary in this AAML. This is just a basic things which are being enhanced, so that there are some aspect of it which are not very predictable from a human perspective. In the sense, I can say, for example, it's not like we are not doing handover. Handover, you put a threshold. Below that threshold, you usually do the handover. But where to put the threshold? That's are all the issues which are being looked at from an AML perspective. So from this, where we are going towards is like, as mentioned by both Manoj and Srihari, is like you're going to a complete AI native thing, not just in network, even the operation, everything. Can we use AI to make the network more efficient? And the last part is like, is what the diagram which Kiran started off. This was recently concluded in the meeting which happened in ITU. So we have an integrated AI and communication coming in, which along with all other aspect of it would basically be what hope all of us would be launching by 2030, which includes all this function. And AI is one aspect which is clearly one of the differentiator. So all the things in blue there are new. All the things in green are from the earlier things. These are being enhanced. The newer one you can see includes sensing. So sensing is one aspect which would also help in AI. So sensing information can be provided to the AI to do more aspects. So like as was mentioned, digital twin, we could actually have a complete city being represented in a digital way. So that would help, like as was mentioned in morning by Uttarakhand thing, that can we completely have a digital twin of the city and then use that. Other things continues to be there. So all of us need connectivity. I find that speed here is quite pathetic. So those issues still continue to be as important as ubiquitous connectivity. So there are efforts being done to integrate satellite. There are efforts being done to add newer technology called RIS. So all of those would further help to improve the connectivity. Along with this, if you get more information, I should be able to process more information and hopefully run the network by itself, completely becoming autonomous. So yes, there are some job losses in the sense whoever is operating the network will not need so much of people to run the network. And hopefully that should help all the operators to provide all of us a cheaper connectivity as well. With that, I will conclude. Thank you.
Thank you. I think we're reaching the end of the session. I have some remarks. First of all, I must acknowledge that the discussions today really thought-provoking and very interesting set of discussions, and the expertise brought to this session is very phenomenal. And what's remarkable though is that we are looking at 2030 and maybe some solutions rolled out a few years before that. But we're having a conversation in 2023. It's very rare such conversations take place on advanced technologies. So there are a few observations I have apart from what we have been discussed today. The neural network-based techniques, if you go back a few years, what I'm noticing is that it has taken about 5 to 6 years when first claims have been made about the success of these technologies, whether it's speech, video, or natural language processing. It took quite a while before we start to see the benefits now today. There is still a big program. Going by the same analogy, if you start now in 2023, there's a good chance that you start seeing the benefits of this technology towards 2030. But that's not going to be a smooth ride because some of these algorithms, especially the ones based on neural networks, reduce a lot of data. And who's going to give the data to the researchers? So this part, I think, needs a very careful thinking, not just from the standards definition point of view, but also defining an ecosystem point of view. So I don't have an answer, but I think it's something worthwhile thinking about. That's what was in my mind. And I also thank Mr. Shivkumar and Ilya for really putting up this session, such a good thing. Perhaps, this needs to be done more frequently, as frequently as we could. Probably share some thoughts and ideas, and this could potentially lead to, some benefits to researchers and the ecosystem on the whole. So I really look forward to, maybe next time speaking about these topics in more depth, and also we can probably arrange some talks that can go into some of these exciting technologies in more depth. I'll stop here. If there are any remarks, we can take some questions also.
Thank you, sir. We're extremely sorry. We are running really out of schedule. We do not have any time left for question and answers. So I would like to invite Dr. Shiv on behalf of the chair to kindly do the honors of presenting mementos as a token of appreciation and gratitude to our speakers. We present to Mr. Rohit Jain, Vice President and Head of Technology, Airtel IQ. We present to Dr. Srihari Vasudevan. We present to Mr. Manoj Gurnani, CTO Nokia, and to Mr. Jishnu A, Principal Architect Technology in CTO's office, Tejas Network. And ladies and gentlemen, we'll be sending across the memento of the chair, sir, Professor Kiran Kuchi. Thank you once again. I invite now Dr. Shiv to kindly propose the vote of thanks. Yeah, and after the group, we'll have a group photograph first. And after that, Dr. Schiff to kindly propose the vote of thanks and close the proceedings of today's summit.
I take this privilege, and it's a great honor for me to put the vote of thanks. It has been, I believe, a great session. When we were planning to design the session, then we thought what and how we should make the difference. So accordingly, we incorporated different type of topics. I would like to thank all our distinguished guests,